say correctly?
Yes,
Suresh?
it is correct. Suresh.
Suresh. Okay. Try to speak my name.
Yeah, you're the Luciano.
Oh,
I'm pronouncing correct? Okay, then I guess we are live. We can begin.
So it's just
Oh, yes, sorry.
uh,
Okay.
okay.
Okay, so
o
let's start.
Suresh só vai
I will
introduzir
introduce
você.
you first and then you can start. Okay. So hello
Okay.
everyone. Welcome again to our Wednesday seminar. Today we have a very special guest, Luciano Fraga. So he will be teaching us how to write a SOAR proposal for the 2026 A semester. Luciano holds a bachelor degree in physics, also a master's degree and a PhD from Federal University of Santa Catarina. He did a postdoctoral from Southern Astrophysical Research SOAR Telescope. He is currently the Deputy Director of LNA, Coordinator of LNA Astrophysics Coordination, Coast, Coordinator of the LNA Institutional Training Program, Manager of SOAR National Office, President of Brazilian SOAR Program Committee, and Interim Manager of the Pico dos Dez Observatory National Office. He is a permanent external professor in Master's Program in Physics at the Federal University of Itajuba. He has extensive experience in astronomical instrumentation and in scientific research in astrophysics, working with stellar astrophysics and star clusters. So he is the perfect person to introduce us how to write a proposal for SOAR. So Luciano, now the stage is all yours. You can continue with your presentation.
Thank you, Suresh. As I was talking Portuguese, this my presentation, I start to talk about how to build this presentation with Rogério Riffel. He's my deputy chair of the Brazilian SOAR TAC. I built this presentation like a guideline for how to fill out the proposal form for to submit a proposal to the SOAR telescope in this next semester, okay, 2016. So here is the outline. So the outline I will speak really fast in the first few slides. I will talk about the LNA overview, about our mission, the origins of LNA. I will talk a little bit about the SOAR telescope, a little bit also about the instruments, but this talk is not about how to observe or how to make like a data reduction of the instruments. I'll be concentrate more about the call of the proposal. I will talk about some important information about this next call. The instruments that we are offering into the 26A. I will give you a little bit of a spoiler about the new instrumentation that we are expecting to offer into 26B. I will talk mainly about studies, just show a few one slide about the first slide of studies. And then the most important about my talk is the phase one form update. We did make some severe changes on the core page in the templates, the dot text and the dot word template. So let's start. So talking about the origin of LNA. So LNA stands for the National Laboratory for Astrophysics. LNA was created in 1985 as part of the National Observatory that is stays in Rio de Janeiro, with the primary mission of operating and managing the Pico dos Dias Observatory. Okay, here in the left is when they were starting building the main building of the most the greatest telescope, optical telescope in the national territory. Is the 1.6 meters telescope. The main mirror has like a 1.6 meter diameter. So this photo was taken in 1979. LNA became an autonomous research unit together with the MCTI, the Ministry of Science, Technology and Innovation, in 2000, as I said. The headquarters in Itajubá, in Minas Gerais. Since the beginning, LNA has played an important role in supporting the Brazilian astrophysics community operation, all the observational infrastructure and enabling the development of scientific instrumentation. So we have a really well-defined mission. The mission is here. The mission is to promote the Brazilian astrophysics through cooperative action. We don't do anything alone. We always talk with our community of what we must to do in the future. Well, by developing and managing observational and laboratory infrastructure that enables scientific discovery and technological innovation. Well, this is a fancy way to say that we, in the bottom of the line, we manage and operate the Pico dos Dias Observatory, and then we also manage the Brazilian participation in the SOAR and Gemini observatories. Okay, so SOAR I will talk about a little bit later, but Gemini is a twin telescope, 8 meters primary mirror in diameter. One is in Cerro Pachón, really nearby SOAR, and the other is in Mauna Kea in Hawaii. Okay, and we also we design and build astronomical instrumentation for those observatories and also other observatories that we are not managing. So this is some photos. Me when I was there at SOAR, I was postdoc at SOAR from 2007 then to 2013. Then I was participating on the CIFS installation. CIFS is IFU spectrography. I will talk a little bit later. And then I was starting to participate on developing the building of the Stellis spectrograph. It's a high resolution two-channel spectrograph. I was here in me when I was there on the installation of the Stellis on the oak of the SOAR telescope. Okay, both instruments are on the SOAR telescope. So this is a SOAR from the inside the dome. Okay, so SOAR is a 4-meter telescope. Is in Cerro Pachón in Chile. The agreement was signed in 1999. For when we signed this agreement, it was stipulated that Brazil had to build two instruments. One for the first generation instrument, this one was SIFS, and the second one was STELIS for the second generation. So this was really important for the Brazilian astronomy community, because it was the first time that we together as a community decide what kind of instruments and what kind of science we are going to do in the future for a really at the time really one of the most biggest greatest telescope, largest telescope in another country. So the first flight was in 2005 of the SOAR Telescope, and the operations begins in 2006. As far as I remember, Kepler was there, right, Kepler? In 2006.
2005. I spent
Ah,
whole 2005 there.
so thanks. So the SOAR consortium has Brazil as the majority member with 31% of the total time. AO, that is now NORLab, UNC, North Carolina University, and Michigan State, also USA University. And Chile as the host of the telescope, they have like 10% of the time. So the 31% of the time means that we, the Brazilians, through the LNA call for proposals for SOAR, we have about 50 nights per semester, 100 nights per year. Okay. So this is this SOAR telescope from the inside. Here you can see the really black box, huge black box. You can see my mouse or no?
Yes, yes.
Yeah. So this is SIPS. The bench of SIPS. There is the bundle of fiber is going up to the ISB, the instrument selector box in the optical side. So we have like two ISB, one in the optical side and the other in the infrared side. So when I'll be talking about the infrared instruments, they are in that side, and the optical ones are in that side. Okay. So here you can see the optical path, the target, the object light comes from the infinite, then hits the N1, the primary mirrors, reach the M2, the secondary, then hits the tertiary, and then goes to one of the select box. This can be like the optical instrument selector box, and then you flip the M3, the tertiary, to the other direction, then the light goes to the other side of the Nesmith box, then it goes to the infrared. Okay. So here we go. The important information about this call for proposals. So the next submission portal, we are planning to open on September 15. We might have some delays by a few days. We will let everyone know if we are going to delay by 1 or 2 days. The important date is this submission deadline is the 15 October at 5 o'clock Brazilian time. Okay. If in the last year we had an extension of the submission deadline, if for any reason we have again extension of the deadline, we are going to announce this through our web page and our LNA email list and decide communications. Okay. The observing window is from the February the 1st till 31 of July. So far, we are going to have 50 nights available. The total number of the nights can change a little bit. We reserve some nights for the digit time, the director discretionary time. Normally it's 2 nights per semester. So now we have these program times, the program types. I'm going to talk about them a little bit later, and some observing modes. Okay, about the instruments. So the instruments offer this on this call is the Goodman, the high throughput spectrography. Goodman normally is the instrument that receives the most of the number or the percentage of or the fraction of the proposal for Brazil. It's about 60 to 70% of the total time goes to Goodman. Triple spec is the second one. Sometimes reach the 30% of the fraction of the time. So Goodman is a high throughput spectrograph, but it has also image modes. So they have like a image mode, the single slit spectrograph modes, and multi-object spectrograph mode. Okay, I will talk a little bit more later on how. Triple specs, near infrared spectrograph. Sun Plus is the adaptive optics module plus an imager. This is SAMI. This is what we are offering for the Brazilian community. You are asking for time for SAMI, okay? And also CIFS, the integral field unit spectrograph. We have 2 visitor instruments, Raptor. It's a high-speed CMOS for occultation. It's really small field of view, but really high cadence of images to make to observe occultations. The PI is Júlio Camargo from the National Observatory in Rio de Janeiro. And also the high resolution camera. It goes inside this SAM. It is a speckle interferometry. The PI is Andrei Tokovini. If you want to ask or submit a proposal for both instruments, you must talk before with the PIs to ask permission to use. We also make available through the SOAR Blanco exchange time 2 other instruments. One is the DECAM, the dark energy camera. It's a wide field optical imager. I think it's 2 to 3 degrees square of field of view. And in new firm is a wide field near infrared imager. So I think the field of view is about half degree square. And the spectral instruments is Stelis. We are planning to offer this instrument on to 26B. And iSpy, it's going to replace Spartan. Also, it's a near infrared imager. It's going to replace Spartan also to 26B. Okay. here the ideas of those slides about the instruments is just to let you know what kind of information you must fill in the forms uh, uh, for the call of the proposal. Okay, when you are select Goodman, you are going to decide if you are going to use the red camera or the blue camera. If you want your observation optimized in the UV, you need to go to the blue camera. If you are going to the red side, the red camera has a fringe suppression, so you must choose the red one. You must have in mind that if you choose one, you cannot change one camera to the other during the night. So if you pick one, you are going to stay the whole night with that camera. In image mode, you are going to decide if you are going to use in image mode or spectroscopic mode. You can fill out the proposal with both in imaging spectrography. But the first part you are going to select the instrument as an image mode, and then you are going to switch and then select add one more setup for the spectroscopic mode. Okay. So for in the image mode, we are going to select filters. We have the zone set of filters, the bezel set of filters, and some narrow filters. The pixel scale of Goodman in image mode is 0.15 arc second pixel. So it is okay to being if the scene is not that good. It's more than 1 arc second, then it is okay to beam. So the full frame field of view is 7.2 arc minutes circular. Okay, field of view. You can make a subset of the CCD, select a region of interest, and in this way you can reduce the readout time for increase the cadence. Okay, so in spectroscopic mode, you can select gratings, the wavelength coverage for the central wavelength. You can select. You also can handle a spectral resolution from 800 to 15,000. Okay, in that way, of course, your spectral resolution depends on the width of the slit. So this resolution for the 0.45 arc second width the slit. Okay. Okay, so we have several slits available. You spectroscopic mode, you can also select sorting filters for blocking the second order grading orders. So we have a PDF explaining which one you have to choose for in each case. Okay, you can go to in the NOAR Lab webpage and check that for details. On Goodman, we have also the atmospheric dispersion corrector. Okay, this is for correcting and avoiding slit losses when the air mass is too low. Triple spec. I know that there is a lot of user of this triple spec at your institute. So the first commission of this triple specs was in the instrument was in blank, was named as Arcoiris. Then the instrument has been moved to SOAR in 2019A. So it's a near infrared cross dispersed spectrograph, single object, long slit, and with no moving parts. Okay, you cannot choose anything on this instrument. That's why it is really high efficiency instrument. Okay, there is a fixity of 1.1 arc second, and this in the spatial direction 28 arc second. You can have simultaneous wavelength coverage from Z of slow to K. Okay, the spectral resolution is about 3500. This viewing is in J band and is 4x4 arc minutes. Okay, some. Some is the adaptive optics. The instrument had upgrade. This called Sun Plus. The upgrade was done by the IAG at USP, the Brazilian University. So Sun Plus plus the imager is a 4K by 4K CCD imager. They have a really high resolution plate scale of 0.0455 arc second per pixel. But this is too much for the Pachón means scene. So most of the time they are using the CCD being 2x2. That leads the plate scale to 0.091 arc second per pixel. So the field of view is 3x3 arc minutes. We have broadband filters, slow filters, and cosine filters. Also narrowband filters. In when you have to use sun, you are going to select sun if you need really good spatial resolution. Some can reach the 0.3 to 0.4 full width half mass when the conditions allows in the visible and near infrared. What that means? So sun has a ground layer laser, okay, in the UV. When the scene is in the ground layer atmosphere, they can correct this. This. If we have a really bad condition, outer layers up in the atmosphere, you cannot do anything with this, with sun. So sun is blinding in the UV because the laser is in the UV, and we have a leakage when using the B filter. Okay, you can see the spot of the guide star on the a little bit of in the background of in the B field. So here is just some sketch of how sun works. We have a laser. The laser launch telescope is in the back of the secondary. So this is the UV laser. Then there is a wavefront sensor that can read the how are the wavefront sensor from this guide star is, and then they correct the GM mirror here to compensate the atmospheric variations. Okay, so here's how really nice is the image of a globular cluster when using a sunny. Okay, tips. So here the instrument, the IFU spectrograph. I am the instrument science of this one. So it's a IFU with a field of view of 15 arc second by 7.8 arc second. The fiber scale is 0.3 arc second per fiber. you can have two gratings. One is 700 grating, and the other is 1500 lines per millimeter grating. You can have a spectral resolution from 4200 to 9500. One using the 700, the other using the 1500. So we are going to have a 1300 spectrum on your science frame. Okay. I'm not going to talk much of these instruments, but this is the image of the IFU. Here is the light path. The anaconda, the bundle of fibers goes from the optical side. So this is in the ISB, optical ISB. This is where the focal plane is. Okay, it's image in the IFU. Then all the lights goes reach this collimator mirror here, and this is another part of the collimator. Then you select a gradient that you want. Then you are going to have a spectrum. Then pass through the camera and goes to the detector. There you are going to have your 1300 spectrum at once. So this is status. Okay, so this status is for the next call of proposal. But I would like to mention that we had the first slide last month. So this is a two-channel high resolution spectrograph. We had a VPH cross-shell. This is somewhere here in the middle, but you can see the two dewars here. This is the red one, is the blue one. So you can have a spectrum from 300 to almost 900 nanometers at one single shot. Okay, and you can have it like two independent tunable slits. I think we are going to have the science verification 2006B. So this is where I would like to spend the most of the time. How much time I have so far? Or I'm really ending of that time.
You have around 15 minutes.
15 minutes, okay. So this is the all the phase one form update that I would like to speak about. So we did some change now. In the past, we had like a scientific case and scientific impact subsections. Okay, this we had just one page for both, and also technical justification. Special instruments requirements in one subsection. This was making confusion. People couldn't have much space to talk about the sample, for example. And then we decided to move on and then put one more section in the core page. So now we have a scientific case, experimental design, and technical description. Okay, and then the preview missions of the proposal and then the preview results of in the field for the PI, we move to the end of the proposal. So the scientific case, so this is the heart of the proposal. Here in this one page, so here where I put some guideline for you to start writing your proposal. Okay, so in the science case, you must state what you aim to discover and why it matters. So what is the global context of your research, or what you are planning to do. So you can divide in four different topics. So the first one is the context, the overall context, and the state of art. So in that part, you are going to describe the knowledge gap. What's in the field is what is the current state, the current knowledge in the fields, and highlight what remains unknown. Okay, and try to write for non-specialists. Most we have a lot of people in the committee, okay, in the TACI, and it's we don't have specialists in all the subfields, okay? So try to think to write for a non-specialist. The second one is submitting is the scientific problem and the objectives. So in that part, we will make explicit the about the problems that we are going to address, and which question you intend to answer with the proposed observation. And in a really small sentence, you are going to make like a bridge with the scientific methodology, okay? You are going to just give a small highlight to what you are going to plan to do with your observation. Just making like a bridge to what you're going to present in the experimental design, okay? All the details go to the experimental design. The impact and the relevance that before was in the subsection, now you are going to have to put that in the this one page and explain the impact of the results. If the objectives of the observation are achieved. So how do you expect that your data will fill the knowledge gap, and how these outcomes will be published, okay? So the second part is the experimental design. So here is the part of the how and with what and the plan. It's the observing plan. Okay, you must think on this part as the part of the sample. Okay, this is the most the sample and the kind of the observing strategy. It is the observing plan. So you must state also here and how the observation will be conducted to achieve your scientific objectives. Okay, so you have the I also divided in four parts. You have the sample and the targets. Here you must describe which objects you are going to observe it and why. You must outline the selection criteria and must justify your sample size. Okay, and if you need if you are going to have some control sets like in my case, I was adding like a peculiar star and a normal star. I was always comparing the number of peculiar star comparable to the normal one. So if you have a control set, you must explain how you are going to use and how you are going to test the hypothesis. We have the observing strategy. So this is we are going to explain the total nights, the number of points, exposure per target, and exposure time, and number of epochs filter. In the way that you are going to you must justify what is the requirement to meet your objective. And the third part is the measure analysis. Here is what you are going to measure. So what are the observables? For example, flux or colors, any radial velocity, anything, and explain how they are going to address your scientific scientific question. Okay, you can briefly indicate about the data reduction that we are going to use, any critical steps like special calibration that you're going to need, and here also as well the models that you are planning to use. Data quality requirements are the why you need this signal to noise. It's not how you are going to measure the signal noise. It's not the estimation of signal noise. The estimation of signal to noise goes to the technical description. But here you are going to explain why you need this signal to noise. If you are doing a pulsation, the pulsation amplitude is about 0.1 millimagnitudes. So how much do you need of signal to noise to detect this variation? Okay. So here the idea is to link all this kind of specification with your science objectives, and then the requirements will determine the total time present in the technical. How much I have more time? This the technical descriptions. So this is the last one. As it is, can it be done? It's about the feasibility. It must in this part you are going to demonstrate how the observation are technically feasible. Okay, so here you are going to explain all the instrument configuration, everything that you are going to use. And here is the part that you are going to describe the required observed condition. Here also is where you are going to provide exposure time estimations. Okay, you are going to demonstrate that, and we are going when you are going to do that, you are going to do that in the worst required observation condition that you plan to have. Okay, then you are going to show how if the required signal to noise ratio is reachable. Okay, none. I know that most of the SOAR instruments don't have exposure time calculator. Okay, but what I suggest in some cases is to use HC from similar instruments on other telescopes, then scaling by the rate of primary mirror. Okay. And here the most important is the total observed time request. So this is where you are going to sum up all the integration times and all the overheads that you have. Okay, and in the proposal you are going to also justify the minimum time acceptable for your proposal. Okay, this is very important because it's not always that we are going to have be award to all the telescope time that you asked for. So sometimes you receive the minimum time, and then we must understand what you are going to do with the minimum time. Okay, so here is I did like a guideline step by step. This is I can send you this presentation. I'm going really fast. This is just sign up and then this had changed. So you are going to select this SOAR button here, and then you go to the SOAR form. Then you click in the SOAR phase 1 form, new proposal. Then you're going to start filling the form. I know that not anybody knows, but if you pass the mouse, if you move the mouse over the cursor of your mouse over the each one of these fields, you can see some tips of what is this the field that you must fill it. Okay. Okay. I will pass a little fast here. So now we have some observing modes. The classical in person is the people that goes to to SOAR to observe there. It's important to say that LNA does not provide any financial support for travel to see Chile or loading at Pachón. Okay, but if you have a grant and once you go there, you can just feel the in-person mode. The most of people will set the classical remote, so we are going to observe remotely. And we are also putting some a few nights in Q observation. Brazil still not paying for ION. It's ION is a SOAR NOR lab Q mode of service observations. Okay, they want Brazil to start paying, but we 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 are advertising already these 5 nights, but nobody's asking those nights. So I'm telling you now here you can select the Q service, and then we have like 5 nights in total for service molding through Aeon. Aeon has only Goodman and triple spec. Okay. You how much time I have more? I can stop at any time.
So you can keep a little bit more, but it's over.
Okay. I'm just I can say this presentation, but we'll just talk a little bit of this kind of program time that we have now. We have this regular proposal. So this is the regular call for proposal that all people will be submitting. Okay. Is the nights that are allocated and scheduled through the semester in the calendar. Okay. We have also the director discretionary timing. This is submitted outside the regular call. We have some available nights as DDT nights, and the people can ask for this night. They must submit a proposal also, and then it's passed through a small TAC, and then we can allocate some nights for that. We have also target of opportunity modes. This is a schedule for really when we don't know when some transient event will happen. Then we have this TO mode. We have large programs, the programs that require multi-semester observing time. And we also have backup proposals. When the observers select a proposal that is using SAM or a really optimal condition as 0.8 arc second and photometric condition, they must also submit a backup proposal. Okay, there is a lot of more information here. I can send you this. I think it's really straightforward to read and have this information just to submit a proposal. So I will finish here.
Thank you, Luciano. Any questions?
I have many, so the guy should start. Start with the students and the ones in there.
Anyone having questions in here? Yes, please.
So it was stated that the SAM-plus imager, it generally used 2x2 binning for its observations. And from my understanding, increasing the binning of an imager decreases its resolving power, but in exchange for higher light sensitivity. So my question is, why is that the general use case for that imager?
Yeah, because if you can see the plate scales, that goes when the binning 2x2 is 0. Nearly 0.1. If you have like a really excellent scene, you are going to have like a 0.3 to 0.4 arc seconds when you are using the AO system, okay? In those cases, you are going to have like a 3 samples pixel in your full width half max, okay? Uh, in that case, it's okay to use one by one. But in most of the case, you have your image with a point, the scene of your image is going to be 0.7 arc second. So in that case, you are oversampling. That's the problem.
Okay, I see now. Thank you very much. I have one more question. Do the target of opportunity proposals, do they trump other proposals that are currently in progress? Like, do they just
They
stop now?
interrupt the other proposal, yes. They interrupt mostly of the proposals. But some of the proposals that have like time critical proposals, they can save the night. We have like a few of them that those nights are not, you cannot interrupt those nights. But the PI of the night that had interrupted night is going to have the 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 back the get back the time that they was interrupted by, multiplied by a number. Okay, if the TO interrupt your night by 1 hour, you're going to have another night about 2.5 hours back.
I see. Thank you very much.
So any more questions in person? Okay, so Kepler, now you can continue with your questions.
Okay, many. So let's start with Raptor. So, is it installed all the time or not? Is it in the telescope?
They are in the bench Cassegrain, so it's
Okay.
available all the time.
Okay. So do we need to have a permission from Camargo to use it, right?
But it is a CMOS, Kepler.
Yeah.
I
You
don't
don't
really.
recommend?
I don't. We bought a good CMOS here, scientific
Uh-huh.
at OPG. We are going to
Yeah.
start testing now. So I
Okay.
will talk to you to start the
Okay.
test. So
Okay.
let's
Okay.
check first. It's not. It's really commercial.
Okay.
No.
CCD. Okay.
Yeah.
It's only for bright
In
objects.
that case, they are only interested in the timing.
Yeah.
They are not
Okay.
interested in the like
Flux.
the variation
Okay.
of
Okay. Okay. So on Goodman, are cosmic ray increasing or is the CCD degrading?
It's a long
Okay.
time that I
Because
do
yeah,
service with good, but the CCD is degrading. The
yeah.
blue,
It seems to me that we are getting hundreds of cosmic rays in 20 minutes or 30 minutes. So it seems to me to be increasing from when it was installed, but that's a question for you.
Yeah,
Okay,
that's,
yeah. Is the fringe suppression working for the red?
yeah.
Okay,
It's only for the red. I think it starts on the 6,000 angstrom, something like
okay, okay. And what about the flexure correction? Because
that.
sometimes the
Earth
piezoelectric.
reflection correction is getting worse and worse.
Yeah, okay, yeah,
But again, it's a long time that I don't observe it.
okay, okay. And what about the ADC? Can it be selected during the night? And
Yeah, at any time. Yeah.
but if you do so, you need to redo all the calibrations, right?
Yeah,
Okay.
it's advisable that you put in the middle of the HC, in the middle of the way, when you
Uh-huh.
the calibration. You are
Yeah,
never going to have the HC in this exact same position that
right.
we observation.
Okay. Yeah.
You can ask the telescope operator that put the HC in the middle there,
Uh-huh.
and then you take your calibration with the
At the
HC.
end. Yeah.
Yeah.
Okay.
But remember, you are going to use the HC with the air mass 1.5 or higher than that.
Yeah.
Okay,
Yeah. Yeah.
lower than that, you should not be 0.4 meter telescope to lower than 1.5.
Yeah. Well, that's a problem for
Yeah,
some
that's
stars. Yeah. What about the EON time is going to be submitted in the regular proposal, from what I
yeah.
understood.
I hope that all the things that I put here, the program types and
Uh-huh.
the variables will be there in the form.
Uh-huh.
I'm
Okay.
testing the developed software for the
Yeah.
form, and it's
Uh-huh.
already there. So I think it's going to be there. So you can ask you for the nights on AO.
Okay.
But
But
but if the NOR lab says that okay, I'm not going to give you
yeah.
Brazilian time to AO,
Uh-huh.
don't worry, your the rank of your proposal is not going to be changed. Then we are going to move your observation to classical remote
Yeah.
observation. Yeah.
Okay. One more question on EON is, do you have to submit two proposals, one for EON and one for not EON? But there are a few objects that we can do on EON and some not. So can we have one proposal with both and try to explain, or do you prefer both?
Yeah,
Two.
you must have two proposals because
Okay.
you not add one or two observer modes.
Okay.
One
Okay.
or-
Okay. My two last questions is, if the DDT allocated to LNA, or do you have to ask the SOAR director?
no, it's the LNA director.
Okay. And the final one, if the tech allocating time for long proposals, or like a fraction, or is it by proposal? Do you judge
I
the
propose.
proposal? Okay. Okay.
What we do here is like in some case we have really bad weather. Some I know some people that are has like the defense date is reaching the time
Yeah.
that they must have the data, and then
Yeah.
we allocate this DDT time to this proposal. We are
Okay.
doing it some case.
Okay.
When we have all good time, then I ask Wagner, the LNA director, if he wants to use. If not, if we receive a proposal, then
Yeah.
I
Okay.
can check that.
Okay. Yeah, thanks. So the final question is, so you have increased the length of the scientific plus technical justification. Is that correct?
Yeah.
Yes.
So
Okay.
you
Good.
were going to have one more page for
Yes.
the So the technical justification was split in two parts. The experimental design, this is the part that is dedicated to the sample. You are
Yeah,
going to describe the sample and the observing plan,
yeah,
and then the technical description. That is where you are going to show the all the technical
yeah.
description of the proposal.
Okay, great. Okay, that's it. Thank you.
Rogerio has one question.
So, Luciano, there was this discussion at the SOAR meeting about SAMOS, that is this instrument that was built by HST, that should be somehow available at SOAR. Do you know anything about it?
They are having some engineering nights. I heard they had some problems with the instruments, so uh, I didn't put any Brazilian nights for that. I was planning to put some advertising on this call to, oh, if you want to use the Samos, send a message to Massimo, the PI of the instrument. But then I think it was too much to put this in this call of proposal. But
Yeah,
we are having like a DDT time. Uh, then if we have like a visitor proposal asking for summons, then we can check if we can do something with this instrument.
okay, perfect.
Okay, so any more questions? Okay, then let's thank Luciano.
It was mute. I didn't hear any claps.
Yes. Thank you, Luciano.
Yeah.
Yeah.
So, Rogério, eu te mando essa apresentação.
Manda, por favor.
Sim.
Aí eu mando para o pessoal na lista aqui. Pode mandar para mim ou para o Suresh.
Não conseguimos encontrar a Teresa.
Não estou te ouvindo, Luciano.